For thousands of years, humans have looked up at the night sky and wondered what lies beyond our tiny blue world. Among all the glowing dots scattered across the darkness, one has always stood out more than the rest: Mars. Its reddish glow made ancient civilizations imagine it as a god of war, a burning eye in the heavens, or a mysterious twin of Earth. Today, we no longer see Mars through myth, but through science. And the truth is even more fascinating than any legend. Mars is not just another planet. It is the closest thing we have to a second Earth. From a distance, it looks strangely familiar. It has polar ice caps, seasons, mountains, valleys, and ancient riverbeds carved into its surface. At some point in its distant past, Mars may have been warm, wet, and possibly alive. That alone makes it one of the most important places in the entire solar system. But Mars today is a very different world. It is cold, dry, and nearly airless. The average temperature on the surface is far below freezing. The atmosphere is so thin that liquid water cannot survive for long. Radiation from space constantly bombards the planet because Mars has no strong magnetic field to protect it. And yet, despite all of this, Mars continues to pull us in. Why? Because it represents a question that has haunted humanity forever. Are we alone, and can we ever leave Earth? Modern science has transformed Mars from a point of light into a real place. We have sent orbiters, landers, and rovers. We have mapped its surface in incredible detail. We have drilled into its rocks, analyzed its soil, and even flown a helicopter in its thin air. Each mission has revealed a world that was once far more Earth-like than we ever imagined. Long ago, Mars had rivers flowing across its surface. It had lakes, maybe even oceans. It had a thicker atmosphere that could hold heat and support liquid water. These are exactly the conditions that life needs. If life ever emerged anywhere beyond Earth in our solar system, Mars is one of the most likely candidates. That possibility alone makes Mars priceless. But there is another reason Mars fascinates us so deeply. It is close. In cosmic terms, Mars is right next door. When Earth and Mars line up in their orbits, they are only about 56 million kilometers apart. That might sound enormous, but in space, it is a relatively short distance. With modern rockets, we can reach Mars in about 6 to 9 months. That makes Mars the only planet in our solar system where humans could realistically travel and survive, at least for a while. And this is where the dream begins. For decades, scientists, engineers, and visionaries have imagined humans walking on Mars. Not just visiting, but staying, building habitats, growing food, creating a permanent presence on another world. To many people, this sounds like the next great step in human evolution. But before we get carried away, we need to understand what Mars really is. Mars is about half the size of Earth. Its gravity is only about 38% as strong. That might sound fun. Imagine being able to jump 3 times higher. But gravity is not just a convenience. It plays a huge role in how our bodies function. Our bones, muscles, heart, and even our eyes evolved under Earth's gravity. In lower gravity, the human body begins to weaken. Bones lose density. Muscles shrink. The heart changes shape. Over time, this can become a serious medical problem. Then there is the atmosphere. Mars' atmosphere is more than 100 times thinner than Earth's. It is made mostly of carbon dioxide, with almost no oxygen. You could not breathe it. Without a spacesuit, you would lose consciousness in seconds and die shortly after. The thin atmosphere also means there is almost no protection from cosmic radiation and solar storms. On Earth, our thick atmosphere and magnetic field shield us. On Mars, that shield is gone. Every day on Mars, you are being exposed to levels of radiation that would be dangerous over time. This radiation damages DNA and increases the risk of cancer, neurological problems, and other serious health issues. No technology we have today can fully protect humans from this for long periods. And then there is the cold. Mars is a frozen desert. Even at the equator, temperatures often stay far below freezing. At night, they can drop to levels that would instantly kill unprotected humans. Any human habitat on Mars would need to be a sealed, pressurized, temperature-controlled environment, essentially a small artificial Earth. In other words, living on Mars would mean living inside a machine. Everything you need, air, water, food, heat, would have to be produced, recycled, and carefully controlled. If anything goes wrong, there is no backup. There is no rescue team just hours away. Earth would be months away by rocket. So why do we keep pushing toward Mars? Because Mars represents hope, curiosity, and the idea that humanity is not meant to stay in one place forever. But the reality of Mars is far more complex than the dream. And this is just the beginning. To truly understand whether Mars can ever become a second home for humanity, we must look beyond its surface and examine the deep physical and biological challenges that come with living on another planet. Mars may look Earth-like from afar, but up close it is one of the most hostile environments we could ever step into. One of the biggest challenges is gravity. Mars has just over 1/3 of Earth's gravity. That might not sound dramatic, but to the human body, it is a massive change. On the International Space Station, astronauts live in microgravity, and even after just a few months, their bodies begin to weaken. Bones lose calcium. Muscles shrink. The heart no longer has to pump as hard and begins to change shape. Eyesight is affected as fluids shift inside the body. Now imagine living not for months, but for years or a lifetime, in a gravity field that is far below what the human body evolved for. We do not yet know if humans could safely have children in Martian gravity. We do not know how pregnancy would work, how babies would develop, or whether growing bodies would form correctly. These are not small details. If Mars is to become a real home, it would need families, not just visiting astronauts. But right now, we have no scientific proof that human reproduction could even work there. Then there is radiation. On Earth, we are protected by a thick atmosphere and a powerful magnetic field that deflects harmful cosmic rays and solar radiation. Mars lost most of its magnetic field billions of years ago. As a result, radiation pours down onto the surface almost unhindered. Over time, this radiation damages DNA and increases the risk of cancer, neurological disorders, and other serious health problems. A human living on Mars for several years could receive a lifetime's worth of radiation exposure. Even with shielding, it would be extremely difficult to reduce this risk to safe levels. Underground habitats could help, but building large underground cities on Mars would require enormous energy and heavy machinery that would all have to be transported from Earth. Now consider the air. Mars has an atmosphere, but it is almost useless for human life. It is thin and mostly carbon dioxide. There is not enough oxygen to breathe, and the pressure is so low that water would boil away. Any human habitat would have to be completely sealed and pressurized. Every breath you take, every drop of water you drink, every plant you grow would depend on technology working perfectly. There would be no natural backup. On Earth, if one system fails, nature often provides alternatives. On Mars, if your life support system fails, you die. Then there is the question of food. To live on Mars, humans would need to grow their own food. But Martian soil is not normal soil. It contains toxic chemicals called perchlorates that are harmful to humans. It has no organic material, no bacteria, no nutrients. It would have to be heavily processed before anything could grow in it. Most likely, food would be grown in artificial greenhouses using hydroponics or aeroponics. That means growing plants in water or mist instead of soil. These systems already exist on Earth, but on Mars they would need to operate continuously for years without failure. Any problem, a disease, a mechanical breakdown, a power loss, could wipe out the food supply. And power itself is another challenge. Mars is farther from the sun than Earth, so solar panels produce less energy. Dust storms can cover the panels and block sunlight for weeks or even months. Nuclear power could help, but nuclear reactors in space come with their own risks and complexities. Everything on Mars would be fragile. This is the reality behind the dream of colonization. It is not just about rockets and landing. It is about creating a tiny, artificial world inside a dead planet and keeping it alive forever. And yet, despite all this, the idea of Mars still refuses to die. Because at its core, Mars is not just about survival. It is about who we are. Mars has always been more than a planet. It has been a mirror for human imagination. For thousands of years, people looked up at the red dot in the night sky and wondered if it was another world like our own. Ancient civilizations built myths around it. Early astronomers believed they saw canals and signs of alien life. And in modern times, Mars has become the symbol of humanity's future, a second chance, a backup world, a new beginning. But the truth is far more complicated. The dream of Mars is driven by something deep inside us. We are explorers by nature. We crossed oceans without knowing what lay on the other side. We climbed mountains with no guarantee of survival. We left our homelands and built new societies in unfamiliar lands. Space feels like the next chapter of that story. But space is not an ocean. It is not a wilderness that can be tamed. It is a fundamentally hostile environment that obeys rules that do not care about human ambition. On Earth, when early explorers faced danger, they could still breathe the air, drink the water, and live off the land. On Mars, every second of survival depends on machines. If those machines fail, there is no second chance. This changes everything. Sending humans to Mars is not like sending ships across the sea. It is like sending them to live inside a submarine on the ocean floor, except there is no ocean, no rescue, and no return. And yet, many people still believe we will build cities there. Why? Because hope is powerful. Because the idea of spreading humanity across the stars makes us feel safe. If Earth is fragile, then Mars becomes a lifeboat. But lifeboats only work if they are easier to survive than the sinking ship. Mars is not. Mars is colder than Antarctica. Its air is thinner than the highest mountains on Earth. Its radiation levels are deadly. Its soil is toxic. Its gravity is too weak for long-term human health. There is no liquid water flowing on its surface. There are no forests, no oceans, no ecosystems to support life. Everything would have to be created artificially. Every tree, every drop of water, every breath of air. And that artificial world would always be one accident away from collapse. Even if we somehow solved the technical problems, the radiation, the gravity, the food, the energy, we would still face something far more dangerous. Isolation. Mars is not just far away in space. It is far away in time. Communication with Earth can take up to 20 minutes one way. That means no real-time conversation, no immediate help, no fast rescue. If something goes wrong, the people on Mars are alone. Psychologically, this is extreme. Humans are social creatures. We are not built to live knowing that everyone we love is tens of millions of kilometers away and cannot reach us for years. Even on Earth, people in remote research stations experience depression, anxiety, and conflict. On Mars, this would be amplified. And unlike Earth, you cannot walk outside to clear your mind. Outside is death. The habitat becomes your entire world. The same walls, the same people, the same limited space, day after day, year after year. This is not just a technical challenge. It is a human one, and it may be one we are not built to survive. There is also a quiet truth most people never think about when they imagine Mars. Even if we reached it, even if we built habitats, even if people lived there, they would not be free. On Earth, if something breaks, you can go outside. You can find materials. You can repair, rebuild, or walk away. On Mars, you are trapped inside a closed system. Every breath of oxygen, every sip of water, every bite of food comes from machines that must work perfectly every single day. If one system fails, it doesn't just cause inconvenience. It threatens everyone's life. That means constant risk, constant maintenance, constant fear. This is not living on another planet. It is surviving inside a fragile bubble on a dead world. And that bubble would have to last for decades, centuries, because Mars cannot be made into a true second Earth anytime soon. To make Mars genuinely habitable, you would need to give it what Earth has: a thick atmosphere, a magnetic field, warm temperatures, and liquid water on the surface. That means changing an entire planet. You would have to release unimaginable amounts of gas to thicken the atmosphere. You would have to warm the planet by tens of degrees. You would have to somehow create a magnetic field to block cosmic radiation. You would have to detoxify the soil. You would have to create oceans, weather, and ecosystems. This is not engineering. This is planetary scale physics. And the energy required to do this is beyond anything humanity has ever controlled. We are talking about manipulating a world with the same power as planetary processes themselves: volcanoes, tectonics, atmospheric chemistry, and stellar radiation. Terraforming Mars would not take decades. It would take thousands of years at minimum, possibly much longer. And even then, there is no guarantee it would ever truly resemble Earth. So when people talk about Mars as a backup planet, they are imagining something that does not exist. There is no lifeboat waiting for us. There is only a frozen, irradiated desert that barely allows machines to function. Now think about this from an economic perspective. To keep a single human alive on Mars, you need massive infrastructure: power systems, life support systems, medical systems, habitats, radiation shielding, food production, communication, transportation, repair facilities, backup systems for every critical component. All of this must be designed, built, launched, and maintained from Earth. And every kilogram you send costs enormous amounts of money. So the question becomes unavoidable. Why? Why would we do this? What is the return on investment? Science? Robots can do most of that for far less. Survival of humanity? Mars is not safer than Earth. It is far more dangerous. Prestige? Pride? Inspiration? Those things are powerful, but are they powerful enough to justify risking human lives and spending hundreds of billions of dollars? History suggests no. Governments struggle to fund hospitals, education, and climate programs. They argue over small budget increases. They cut science funding. They debate infrastructure. The idea that they would commit to a multi-decade, multi-trillion-dollar project to maintain a tiny human outpost on Mars is optimistic. Even private companies face the same reality. They must make money. They must convince investors. They must justify the cost. There is no clear business case for Mars colonization. No products to sell. No resources that are easier to get than on Earth. No markets waiting to be served. Mars is expensive, dangerous, and isolated. That is not how successful ventures begin. And so, slowly, the dream runs into reality. Not because humans are weak, but because the universe is harsh. Even if we put aside cost, danger, and infrastructure, there is one final, insidious barrier: time. The universe does not wait. The timelines required for interplanetary travel are long. To reach Mars using current propulsion technology, it takes roughly 9 months each way. That is 18 months of travel, plus whatever time you plan to stay on the surface. Realistically, a crewed mission could last 2.5 years. 2.5 years in microgravity, exposed to cosmic radiation, dependent on life support systems that cannot fail. 2.5 years in a hostile environment with no chance of immediate rescue. That is longer than the duration of any prior human spaceflight by an order of magnitude. And during this time, every single day is a battle against physics, biology, and chance. Bones weaken, muscles atrophy, cardiovascular systems degrade, vision can be permanently damaged, immune defenses falter, radiation chips away at every cell in the body. And unlike the International Space Station, Mars is not just low Earth orbit, it is deep space. Communication is delayed by up to 20 minutes each way. There is no real-time support. The crew is truly on its own. If something goes catastrophically wrong, no rescue can arrive in time. There is no abort option. Every single decision, every repair, every contingency plan must succeed because failure is permanent. Survival on Mars is therefore not just a technological challenge. It is a biological and psychological one. The human body evolved under one gravity. Mars provides only a third of Earth's gravity. Microgravity during transit and partial gravity on the surface will disrupt every system that evolution tuned over billions of years. We have no long-term data on human survival under these conditions. We do not know if there are tipping points, thresholds where organs fail, immune collapse accelerates, or radiation effects compound with microgravity damage in ways that are impossible to anticipate. And even if humans survive physically, what about mentally? Isolation, confinement, monotony, and distance from family and home create psychological pressures that we barely understand. Decades of analog studies and submarine missions hint at problems, but nothing compares to months alone on a barren planet millions of kilometers from Earth. Stress, anxiety, and interpersonal conflict could become lethal if compounded by equipment failure or medical emergencies. All of this combines into a stark reality. Sending humans to Mars is not just expensive, it is extraordinarily risky, with consequences that could be permanent, irreversible, and deadly. And even if we somehow solved all the biological, technical, and logistical challenges, there remains the philosophical question: why? Mars offers no essential resources for humanity, no untapped energy source, no economic payoff, no guaranteed survival advantage. Its soil is toxic. Its water is mostly frozen. Its atmosphere is unbreathable. Its radiation levels are lethal without massive shielding. Living there means dependence on machines, constant maintenance, and unwavering vigilance. It is a survival exercise, not habitation. And when we weigh these factors against the costs, hundreds of billions of dollars, decades of effort, and countless lives at risk, the picture becomes even bleaker. From a scientific perspective, robots can explore Mars with none of these risks. They can drill, analyze, photograph, and even search for signs of life. They can remain on the surface indefinitely, collecting data continuously without fear of radiation, bone loss, or psychological collapse. From an exploration perspective, the human presence is symbolic rather than necessary. A human on Mars is inspiring, yes, but that inspiration comes at an extraordinary price. And from a practical perspective, the numbers do not add up. The laws of physics, the limits of biology, the staggering logistics, and the enormous cost all converge to create a barrier that may never be crossed. Optimism, imagination, and determination alone cannot overcome these fundamental constraints. We can dream, but the universe imposes limits that cannot be negotiated. It is not a question of willpower or engineering genius. It is a question of physics, chemistry, biology, and economics intersecting in ways that make Mars colonization not just difficult, but possibly impossible within any meaningful human time frame. This is the sobering reality that most people never confront. It is easy to imagine humans hopping between planets like in science fiction. It is easy to believe that motivation and technology will conquer all. But the universe does not yield to hope alone. It yields to the immutable laws of nature. And when we confront them honestly, Mars is not a frontier to settle. It is a mirror reflecting how fragile and unique our existence truly is. Earth is not a stepping stone. Earth is the home we cannot replace. Every other world is a challenge on a scale that dwarfs our greatest accomplishments. And in that light, we must ask ourselves, if Mars is so inhospitable, so distant, so dangerous, why would we risk everything to go there when our own planet still teeters under the threats of climate change, conflict, and ecological collapse? The answer is complicated. Inspiration, exploration, pride. But none of those justify the immense cost, risk, and fragility of life on Mars. The more I study the physics, the biology, and the logistics, the more the dream begins to appear less like destiny and more like a cautionary tale that some ambitions, no matter how visionary, are bounded by the realities of the universe itself. Mars is not the answer. Mars is a test of our ambition, our courage, and our wisdom, and perhaps a reminder that Earth is the only home we are truly equipped to preserve. Even if we accept that humans might one day survive on Mars, there remains the ultimate constraint: time and scale. Terraforming Mars, making it genuinely habitable for humans without constant life support, is a project that dwarfs anything we have ever attempted. We are talking about creating a magnetic field, thickening the atmosphere by orders of magnitude, warming the planet, and producing liquid water. We would need to engineer ecosystems from scratch, stabilize climates, and transform the soil so plants could grow. The energy required for such an endeavor is beyond comprehension, likely exceeding anything humanity could generate for centuries. And even then, success is not guaranteed. Planetary scale engineering is uncertain, uncontrollable, and dependent on physical and chemical processes we barely understand. In short, Mars will remain hostile for the foreseeable future, and colonization, in any meaningful sense, is probably a fantasy. This is where the lesson becomes existential. We are not just considering logistics or technology. We are confronting the limits of our species and the fragility of our civilization. If Mars is inhospitable, as the physics and biology suggest, then the question becomes not, how do we go there? But, how do we survive here? The cosmos is indifferent to our hopes, dreams, and ambitions. There is no guarantee that intelligent life will emerge anywhere else. In fact, everything we know about the history of life on Earth suggests that intelligence is astonishingly rare, a product of contingent events unfolding over billions of years. Oxygen accumulation, surviving global glaciations, the emergence of multicellular life, and the slow evolution of human-level intelligence, all of these were fragile, improbable, and easily disrupted. The odds of this sequence occurring elsewhere are exceedingly low. The implications are profound. If humans are indeed alone, then the responsibility to preserve intelligence, curiosity, and knowledge falls entirely on us. The universe has given us a unique opportunity, the chance to explore, understand, and witness existence from a conscious perspective. If we fail, if we destroy ourselves through war, environmental collapse, or technological hubris, then consciousness may disappear entirely, at least for billions of years, perhaps forever. This is both a terrifying burden and a rare privilege. Our survival is not just a personal or national matter. It is a cosmic imperative. We are the universe contemplating itself. Every choice we make, from preserving biodiversity on Earth to exploring the stars responsibly, carries consequences far beyond immediate human concerns. And yet, there is room for hope, for measured ambition. Mars can still be studied. Robots can explore its surface indefinitely, drilling into the crust, sampling ancient rocks, and searching for signs of past life. Satellites can map its climate, geology, and atmosphere. These efforts advance knowledge at minimal risk and cost compared to sending humans. We can understand Mars without putting lives in jeopardy, without gambling with civilization's future. Human exploration, while inspiring, is not necessary for science. And perhaps inspiration itself can be channeled into preserving Earth, solving global crises, and preparing humanity for the future, a future in which space travel, if it occurs, will be undertaken with full respect for physics, biology, and economics. Ultimately, the story of Mars is the story of humans confronting the universe honestly. It is a lesson in humility, that not every dream is immediately attainable, that ambition must be tempered by reality, and that the cosmos sets rules we cannot bend. It is also a story of hope, if a grounded hope, the hope that we can survive, thrive, and flourish here on Earth, while exploring safely and sustainably beyond. Our species may one day venture to the stars, but only if we first master the laws of nature, the limits of biology, and the responsibilities of civilization. Mars is not the final frontier. Earth is our home, our proving ground, and our sanctuary. So when you look at the red planet in the night sky, remember this. It is not a destination waiting for us to conquer. It is a reminder of the fragility and preciousness of life, of intelligence, and of civilization. The laws of physics, the limits of biology, and the scale of the cosmos all converge to make interplanetary colonization far more difficult than we often imagine. But in acknowledging that difficulty, we also recognize the unique opportunity humanity has been granted to understand the universe, to protect life, and to ensure that consciousness continues. Perhaps we are alone. Perhaps intelligence is vanishingly rare. But that rarity is not a curse. It is a charge. It is a call to protect, to explore responsibly, and to ensure that the light of understanding continues to shine, even in the vast, silent cosmos. Thank you for listening. Tonight, look up at the stars, and remember, we might be the only ones looking, the only ones capable of understanding, and the only ones entrusted with the responsibility of preserving intelligence in the universe. That is a heavy burden, but it is also an extraordinary privilege, one we must cherish and safeguard with every choice we make.